This example comes out of section 9.1, the beginning of chapter 9, exploring rational functions using transformations. So before we start doing anything with rational functions, we better decide or describe what a rational function is. It's anything that can be written as f of x equals p of x over q of x. So essentially it's our equivalent to a fraction. It's going to look something like a fraction where the numerator and the denominator are both polynomial expressions, and of course you can't divide by 0. So if I write down some examples here, we can choose which ones are rational expressions and which ones aren't. So here's a whole list of functions here. I've called them different things just so we can distinguish between them: f of x, y equals, g of x equals, h of x equals. You'll see all these. The first one, definitely 50 could be considered a polynomial expression, pretty simple one, as is x, but definitely that is a rational function. Second one as well, polynomial over polynomial. The next one is not, because it's got this square root in it. And if you remember, our definition of polynomials did not include having exponents like 1/2 or square roots in it. So this one is not a rational expression. The next one is, for sure, polynomial divided by polynomial. P of x is not, given that it's got this exponential in it, 7 to the x. Now we've seen those before in the course, but that won't come up in chapter 9. It's not a rational expression. And this next one, even though it's factored, it definitely is rational. It makes our life easier in most questions that it is factored, but that is definitely a rational expression.